Alright guys, welcome to Learnlyte. In this video, we're going to be talking about object-oriented programming in Python. Alright, so let's get started. So what is object-oriented programming? When writing programs, there are generally two approaches. The first is functional programming, which is what we've been doing thus far. This involves writing different functions to accomplish different tasks, where the entire program is pure functions alone. The second approach is object-oriented programming. It is quite different from functional programming. As the name might suggest, object-oriented programming involves creating objects that can model real-life scenarios or represent real-world things. The programmer creates various classes, which are used as the blueprint to create these objects in programming. So you probably have a few questions such as, what is a class? Well, let's take a look. Well, think of a class as the blueprint for an object. It tells us what object is being created, any properties the object may have, or any actions that the object can perform. And in object-oriented programming, classes are what we use to create the various objects. Without defining a class first, we can't create any objects. So your next question is probably, what are objects? Well, let's get into it. Objects are abstract in nature. They can be anything that the programmer desires. The programmer can give these objects any properties or attributes they want, and the programmer can make these objects perform any actions they desire. With this in mind, you can see how a programmer can make objects in programming to model any real-world object or entity. Example, a programmer can create a dog object in programming with different attributes such as name, age, and breed. The programmer can also have the dog object perform certain actions such as bark and bite. As you can see, this dog object in programming closely models a real dog which can be found in the real world. So with all this explanation, you probably have some questions, and that's alright. But I feel like the best way to learn is through example. So right now, let's get our hands dirty and let's get into some code. So let's start by learning how to create some classes and how to create some objects. Alright. So what I'm going to do here, I'm going to bring up IDLE. I'm going to start by opening a file I have here. Object-oriented programming, which is basically an empty file. And let's begin by creating some classes. So there are generally two approaches to create classes in Python, and I'm going to show you both of them. So let's create a class called cuboid for now. So to begin, we simply begin with the keyword class, followed by the name of the class. We're going to create a class called cuboid, and followed by parentheses and the colon. And then inside here is where we're going to specify what properties the objects created from this class will have and any actions they can perform. But for now, I'm just going to show you how to create the class. So I won't specify any properties or any actions that the object created from this class will have or be able to perform. So since I won't be specifying any properties or attributes, or I won't be writing any methods, I'm just going to have pass right here, which is basically a Python keyword for do nothing. And that's pretty much it. That's how we create a class in Python. And generally, as a rule of thumb, you see a lot of programmers do this, where inside of the class they'll have triple quotations, and inside these triple quotations they'll have basically information as it regards to the class. Alright, so inside the triple quotation I'm gonna say this class represents a cuboid and end with the triple quotation. So this triple quotation is basically a docstring, and programmers use the docstring to basically tell what the class is about. So in this case, we're going to say this class represents a cuboid, and this class is not specifying any attributes or any methods or actions any objects created from this class will be able to do. So for now, we just have pass, which is a Python keyword for do nothing basically. So let's go ahead and save, and we hit run. And that's it. That's how we create a class in Python, or one of the ways we can create a class in Python. And what I'm going to do over here in the script, I'm going to create an object. So I'm going to have a variable called box, because a box is a cuboid, and now I'm going to create the object. And to create the object from the class, we simply call the class. So we call cuboid, and we have parentheses, and we go ahead and hit enter. And just like that, we have created an object and stored it in the variable box. So if I were to say box now, we get main, we get underscore underscore main underscore underscore cuboid object at this memory location. And just like that, we have created a cuboid object right here and assign it to the variable box, right? And if we call box, we get all of this, which is basically a cuboid object at this memory location. So as you can see, we've successfully created a class and created a object as well. So this is one approach to create a class. I'm going to show you another approach that you may see other programmers do. So I'm going to create a class called Sphere. And to do that, we first begin with the keyword class, followed by the name of the class, which is Sphere, followed by the parentheses and the colon. But inside of the parentheses, you may see the keyword object, right? Followed by any docstring describing the class. So I'm going to say this class represents a sphere. And with the triple quotation for now, I won't be specifying any attributes or any actions any object created from the sphere class will be able to do. So since I won't be specifying any properties or actions, I'm just going to have pass right here, which is, as I said before, tells Python to basically create the class and just don't do anything. All right. So you're probably wondering, what is this object right here? What does this keyword object mean? Well, you should know that Python is a object-oriented language, which means that a lot of the things in Python, such as ints, lists, tuples, and dictionary, are all objects. They're all objects in Python. And all objects in Python basically inherit from this global object, and that global object is this object right here. You probably don't know what that means, but in future videos I'll talk about inheritance. But all you have to know is that Python is an object-oriented language, and all the things in Python, such as floats, integers, lists, tuples, are all objects. Even the objects we create from our classes are all objects as well. And all objects are basically linked to this global object. All objects are basically linked to this global object right here. And you may see some programmers do that, but just be sure that these two are basically equivalent. They both produce the same result, and they're just different approaches. One, they pass in the object here, and another approach, they don't pass in anything. Because by default, as I said before, all objects created in Python are automatically linked to this global object by default. So there's no need for you to pass it inside up here, but you may see some programmers do that, and I just want you to know that they are both equivalent. They both produce the same result. So let's save. Let's hit run. And now I'm going to create a variable called ball. And now I'm going to assign a sphere object to that variable. So to do that, I simply call the class sphere. And I go ahead and hit enter. And just like that, I've created a sphere object. So if I were to call ball, I hit enter, you can see I get main sphere object at this memory location. And also, if I were to say type, type, you can see if I were to pass something like 8 into this, you already know what to expect. I would get a class int, right? So what do you think would happen if I were to pass my ball into this type object? Well, let's see what happens. I pass ball into the type function, I should say. Go ahead and enter. I get class main.sphere. So as you can see before, when I pass 8, I get class int. And when I pass ball into the type function, I get class main sphere. So what this tells you is that this is a very powerful feature in Python. It allows us to basically create our own data types. So we know that 8 is an integer, and integer is a primitive data type in Python. But here we have our own data type, which is a sphere. And this is very powerful as object-oriented programming in Python allows us to create our very own user-defined data types. And you can tell it is a user-defined data type by the main in front of it. So we have main.sphere versus for the 8 we just have class int. And here we have class main.sphere. So the main tells us that it's a user-defined data type. So if I were to say type and I pass the empty list into it, go ahead and enter, I get class list. So that's a built-in data type, right? And if I were to basically come up here again and I copy this piece of code right here, paste it down here, and I were to say type, and I pass box into it, you see I get class main.cuboid. So I tell that this cuboid is our user defined data type, which is of type cuboid. And this one is of type sphere. Okay, all right. And that's it for this video. So let's quickly do a recap. So in our recap, we talked about object-oriented programming and functional programming. So we more or less know the difference between object-oriented programming and functional programming. We learned about objects and classes. So in the example, we created the cuboid class and the sphere class. And we also created some objects. And we simply create objects by simply calling the class. And we assign those objects to variables so that we can better access them. All right, and that's it for this video. If you have any questions, please leave them in the comment section below. Please like, share, comment, and subscribe for more content. And always remember to hit the notification bell so that you will be notified whenever a new video is posted. And once again, I thank you for watching.